Alright, this video is about calculating correlation, calculating the line of best fit using slope and y-intercept, and calculating the standard error. Now, for this information, this data is x and y. It represents prices on cars, the sticker price of a truck versus the selling price of a truck. So first we want to do is we want to calculate correlation. How closely is these numbers calculated? So for this, we're going to use, here I'll put it over here so you can see it. I'll do quote equal correl, and then you put the x's, in, and you put the y's in. All right, and that will print your correlation. That'll calculate your correlation. So I'm going to do equals correl. See, it found it. And then I'm going to put in all the x's. You highlight the x's all the way down to the bottom. All right. And then you put in a comma. And then you highlight all the y's. Make sure you highlight them in the same direction, starting from top down. Then you close it off with the parenthesis, and you press enter. So our correlation is 0.9985. So it's positive. It's a positive number. So if we were to do a scatter plot, this would be a very good fit line because it's almost close to 1. 1 is perfect, and this data is very correlated. Now we want to figure out our line of best fit. So we're going to do slope. So this is the equation for slope. This is equal slope. Oops. And then, but this one, you put in the y's first, then you put the x's in. All right, that's what that's going to look like. So here we go. Equal slope, found it. Known y's, so we're going to go top down. We're going to put in all the y's, all the way. Go back up. Put in our comma. Now I'm going to do known x's, so I'm going to top down. Make sure you do it in the same direction that you did the y's. Go back up. I need to put my parenthesis in. Close my parenthesis and enter. Okay. My slope is 0.851. All right, now let's get my y-intercept. The y-intercept is intercept. And you put the y's in first, then the x's. All right, so equals intercept. Oh, I found it. Let's put in the y's. I'm going to go put my comma in. Comma. Let's put in our x's. All right. Go put my parentheses in and enter. Okay, so my y-intercept is 0.435. Now we're going to need count for our standard, so I'm going to show you how to do count. You go equal count, sorry, I want it capitalized. Count, and then I'm just going to use the x's, all right? You can use the y's or the x's, doesn't matter, because there's just as many of the same. So we're going to do equal count. Oh, there it is, count. And we're going to count them. How many of these do we have? And we're going to go back and close this off. All right, there's 23. There's 23 numbers, so that means our degrees of freedom is going to be 23 minus 2. We need that for our standard error. Now, our equation here, just so you know, it's going to be y cap equals 0.851x plus 0.435. We're going to use this equation to figure out y cap. Y cap is our predicted y value based on our linear equation. So we're going to build this block here, C2. We're going to do equals 0.851 times our x, which is A2, plus 0.435. So our predicted amount using our formula is 10.987. Now we don't have to do that for every single block because we can click on C2, go to the bottom right hand corner until you get a black plus sign and drag it down, and it will automatically calculate every y cap. There's all your values. Now we're going to build the formula for y, which is B2, minus y cap, which is C2, and then we're going to square it. All right, so we're going to do equals parentheses B2 minus C2, close parentheses, then do shift 6, which is your exponent symbol, 2. Press enter. Now that's the one for D2. Once again, we're going to highlight D2, go to the bottom right hand corner, drag it all the way down to D24, let go, and there are all your y minus y cap squareds. Now we want to sum all these because we need it for our standard error. So here is our sum. So right here, we're going to go up to get the sigma sign, push sum, and then make sure it's D2 all the 24s. Is D2 all the way 24? All right. Yep, those are all them. And then we're just going to press enter. So our sum is 0.271782. Now our formula, you're going to have to pay attention here. Our formula, which I'll write it down here, is going to be, quote, equals parentheses, and it's going to be the sum of all our y squareds, the sum of those things, divided by our degrees of freedom. And then we're going to square root it, so we're going to raise it to the 0.5 power. 0.5 is actually square rooting something. So this is our formula for standard error. All right, I'll put it right here, standard error. This was from lesson 9-3. So here we're going to go equals parentheses. We're going to click on D25. All right, go back up here. Divided by, our degrees of freedom is 23 minus 2. We don't have to write that because 23 minus 2 you can do in your head. That's 21. I'm going to close the parentheses, the exponent symbol, which is shift 6, and then 0.5. So our standard error is 0.113762905. So these are all the things: correlation, slope, intercept, count, standard error, that you are going to calculate. Put this over here. There. And I'll give you this Excel sheet as you go through the video, so you can repeat it with your data. And then I'm going to provide you a data on cricket chirps versus temperature. And you have to come up with correlation, slope, intercept, count, and standard error.